Okay, here's a problem where we've got a fourth degree polynomial. So we've got negative x to the fourth plus 3x squared plus 3x minus 1. I've taken that function and I've put it into my graphing calculator on the left-hand side of my screen. I've calculated the max value and the two zeros, the two real zeros that exist for this graph. So I'm going to reproduce this by plotting the maximum. That's going to be 1.4, comma 5.2. Then I've got a zero, a real zero at 2.1, 2.1 comma 0. And I also have a 0 at 0.3, 0.3 comma 0. There's a y-intercept that looks like it's happening at -1. So I'm going to just kind of sketch what's going on here, reproduce it on my paper. The zeros, the real zeros, are your x-intercepts. So 0.3 and 2.1, there's two of them. The maximum comes from the y value of the turning point. So the maximum is going to be 5.2. There is no minimum. So there's no low point where the graph goes from decreasing to increasing. This graph is increasing, 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 increasing until it gets to this turning point. Once it gets to the turning point, it changes from increasing to decreasing. So the x value at which this happens is 1.4. So from -infinity to 1.4, the graph is going to be increasing. And from 1.4 to positive infinity, the graph is going to be decreasing. So I'm going to write those intervals down here. From -infinity to 1.4, the graph is increasing. And from 1.4 to positive infinity, the graph is decreasing. Our intervals of increasing and decreasing are always parentheses for those intervals. They're open intervals.